Hi guys, you're welcome back to Tindanius IBM YouTube channel. Subscribe for more interesting videos. Today we are going to consider dimensional analysis. It is also called dimensional method or dimensional equation. So either dimensional method or dimensional equation. They are the same. So now when we say dimensional analysis, what are we trying to say? Or what do we mean by the term dimensional analysis? So dimensional analysis is a method that shows how a quantity is related to its constituent basic or fundamental quantities and other quantities. That's basically dimensional analysis or dimensional method. You understand the definition more when I start with examples. Okay, but take note of this. How do we know that you are taking the dimension of a quantity? How do we know? Or what shows that one is taking the dimension of a physical quantity? So when I have the letter A, B, and C, and I want to take the dimension of the letter A, what shows? This what will show that indeed I'm taking the dimension of A. I'll put the quantity in a square bracket. Please take note, not curly bracket. A square bracket this way. When I want to take the dimension of B, here I'm assuming A, B, C is my physical quantity. So I'll do it this way to mean that I am taking the dimension of B. Similarly, when I want to take the dimension of C, to take this format, then just write the corresponding whatever. Are you okay? Good. If I want to take the dimension of a quantity, let's say mass this way, I will not write the dimension of masses. I will just write mass and I'll put the quantity in a square bracket to mean that I'm taking the dimension of of this quantity called mass. Are you okay? Good. So now let's learn the dimension of the basic or the fundamental quantities. It's very, very necessary. When we are done with that, then we can now add or modify those quantities into another form. So for now, let's see how we can master the dimension of physical or basic, that's basic or fundamental quantities. Then we'll now add the others like the derived quantities. Are you okay? But before you understand the derived quantities, how to take the dimension of a derived quantity, you should be able to understand well the dimension of basic quantities. Are you okay? Now, we have 7 independent quantities or 7 basic or fundamental quantities. One way to remember them is using the acronym META-SLIT. So we have META-SLIT. So my M here denotes mass. My E denotes electric current. So in short, let me write current over here. Then my T will mean that's thermodynamic temperature, or in simple terms, temperature. I have my temperature over here. Then my A is amount of substance or number of moles. So I have my amount of substance. Don't worry, we'll take amount of substance as a major topic in the future in chemistry. Are you okay? Then my S denotes separation. Separation. Then my Li denotes luminous intensity. Then lastly, my T denotes time. So this is just an acronym to remember all the 7. So if I want to take the dimension of these basic quantities, we learned that you have to put them in square bracket to mean that you are taking the dimension of that quantity. So let's say this is the dimension. So this is the quantity, and their dimension. So I'll put this in square brackets. Then I'll put this in square brackets to mean I'm taking the dimension. So mass here will be capital M, please, not small m. The dimension of current is capital I. Then the dimension of temperature is theta. The dimension of amount of substance is capital N. The dimension for separation is capital L, and the amount of the dimension for luminous intensity is J. It's not like J, but it looks like J this way. This is the dimension of luminous intensity. Then lastly, we have the time. The dimension for time is capital T. So please take note. Note the difference between the dimension of time and the dimension of temperature. Temperature is theta, while time is what? Is capital T. So generally, this is how to take the dimension of a basic or fundamental quantity. As simple as that. Just write down the quantity and put them in square bracket to mean that you are taking the dimension of that particular quantity. Take note, we do not take dimension of a number. Why? Number is dimensionless. So we don't take dimension of what? Of a number. Are you okay? When we solve more examples, we will realize we will encounter numbers somewhere and we will learn how to go about it when we see numbers. Are you fine? Yeah, so basically, this is the end of the lesson. Okay. But before that, let me hammer on the separation. Someone asked me, what's the meaning of separation? Separation is what at all? Separation. Now, see, at first, when you are being told to list the physical, that's the fundamental or basic quantities, you will list the 7, and the last one, you write length. You used to state length, but here, the length will fall under separation. Okay. Someone will be wondering, why didn't I write length here? Length is a separation. Why are we saying length is a separation? What is length? Length is just the interval between two fixed points. So I have point A over here, and I have another point B over here. You see the interval, you see the distance between these 2 points is what we call what? It's a length. You see, this is a length, and that's separation. But when we say length, for length you are limited. You are trying to tell us that whenever you have an interval between 2 points, it's length. Do you understand it that way? Now, let's use another example, height. When I want to take your height, when you are here this way, I want to take your height, maybe from your foot to, let's say, your shoulder level. So this is 1 point and another point. Again, see the interval between these 2 points. You see, it's length. Meanwhile, you are measuring height. So you are trying to say that when you have all distances, so all distances are being incorporated into what we call what? separation. Do you understand? So when we talk about separation, that is the distance between two fixed points. Example of the separation we are talking about, we can have length, we can have our height or depth, we can have our width, we can have our breadth, we can have our radius, we can have our circumference, we can have our distance, we can have our displacement, we can have there are many. We can have even diameter. Just remember that all this will fall, when we compress this, it will fall under what? Separation. So the dimension for length is what? Is L. The dimension for height is L, width L, breadth L, radius L, L. When I'm taking the dimension for all, are you okay? So simply, the dimension for separation is what? Is capital L. Thank you. I'll see you next time. Subscribe for more interesting videos. Our next meeting, we'll be talking about how to take the dimension of derived quantities. Bye.